Lesson 32 notes video. So this is the first lesson where we're looking at these three new functions where we're trying to check out what's going on with these, and these three functions are the ones that we have not looked at yet, specifically because they have a different feature compared to the 6 functions that we looked at so far. So those functions are a rational function, which is the equation 1 over x, an exponential function, which is the equation 2 to the x power, the variable is the exponent, and a logarithmic function, which is the log base 2 of x. Again, we wouldn't expect that you've seen this before, but we will learn how to graph it and what it means. So remember, an equation can be represented as a graph, a table. A function can be represented as an equation, a graph, or a table. So we're going to look at those with these three different functions. Now, before we do that, here's what makes these different. They all have asymptotes. Now, 2 of these functions have one asymptote, 1 of these functions has two asymptotes, but they all at least have one asymptote. And we have not really looked at any functions yet that have an asymptote. We've talked about it, we talked that they exist, we haven't looked at them in depth. So let's review what an asymptote is. So there are these dotted lines that show the shape of the graph. The graphs get closer and closer to the asymptote, so they never cross the asymptotes. Vertical asymptotes occur at x values, like this, which could make the denominator equal to 0, or the function is no longer going to give us an actual answer. It would be an undefined solution. Okay. Log functions have vertical asymptotes. Okay. Horizontal asymptotes occur, okay, where we have this type of asymptote, like you see here, and those occur in exponential functions. And then our rational function, as you see here, has both a vertical and a horizontal. Keep in mind, all vertical lines are x equals, so vertical asymptote is always going to be x equals whatever number it is, and the horizontal asymptote is always going to be a y equals whatever number it is. So let's look at the base graphs here for these different functions. Okay. Now you can obviously type these points in. You can also feel free to open up a Desmos calculator separately to get these answers. Okay. I'm going to just run through them mentally, and then we'll check it down here. So 1 over negative 1 is just going to give me negative 1. 1 over negative 0.5 is going to give me negative 2. 1 over 0.5 is going to give me positive 2. And 1 over 2 is going to give me 0.5. So I see these little kind of semicircle sets. So let's click on what the graph should look like, and there you go. So it kind of has 2 parts to it, right? It has this curved part here and this curved part here in quadrants 1 and 3, right? And if we zoom in a little bit, you see the green dotted line and the blue dotted line? Those are the asymptotes. So the green line is the vertical asymptote, the blue line is the horizontal asymptote. So this is called a rational graph, Every rational graph is going to have both a vertical and a horizontal asymptote. Now they can move around, but they're always going to have a similar look and shape to this. So let's look at a different type. So here we go. Now hopefully you remember from our lessons from 30 and 31 what these different numbers do. So this negative 3 on the outside shifts the whole graph down 3. This plus 2 on the inside shifts the entire graph to the left 2. Okay? So from there we can type in our different numbers here. So for negative 3, we're going to get negative 4. Negative 2.5 should give us negative 5. Negative 2, if you type a negative 2 in here, negative 2 plus 2 is 0. You cannot divide by 0, so you get undefined. Negative 1.5 here should give us negative 1. And then 0 here should give us 1. Oops, nope, should give us negative 2.5. All right, let's check that by typing in our equation, and now you see everything fits. Notice how this looks really similar to the graph we just did on screen 4. It's just the entire thing has been shifted, as I mentioned earlier, down 3, so down 1, 2, 3, and then left 2, 1, 2. Okay? All right, so what are our different components? What's the shape of these graphs? So I would call this that it's a two-sided curve, right? It has 2 separate sections, right? Okay. Are there any x values that don't give a y value? Yes, right? We got those undefined. It was at the vertical asymptote. Are there any other x values that can be included? Yes, of course there are. right? Doesn't this line continue to go to the right forever? Doesn't this line continue to go to the left forever? So of course there's more. How do we show all the values could be included? We need arrows on both ends. What's the name of the functions? We went over that, but it's a rational. Are there any asymptotes? Yes. We have one vertical and one horizontal asymptote. Okay. Did we avoid crossing dotted lines? Yeah, we didn't cross the lines. We did not cross the lines. Okay. All right, so that's what we have for that. So that's called the rational graph. It has the vertical asymptote, it has the horizontal asymptote, and it's going to look like what you see right there. Okay? Okay, so now let's look at the next set of graphs. So this is the exponential because the exponent, the variable, is in the exponent. Okay? All right, so we're doing each of these. Again, if you need to break out and go to Desmos.com, open a calculator to type these in, you can do that. I'm just doing these mentally. So 2 to the negative 2 is like 2 squared, which is 4, but then remember you can't have a negative exponent, so it's like doing the reciprocal, so it's 1 over 4, or in other words 0.25. You can put it either way. 0, everybody should know that. 2 to the 0, anything to the 0 is 1. 2 squared is 4. 3, 2 to the third, or 2 cubed is 8. Now you kind of can already see with these points what this line should look like. Let's click it, and there we go. Okay, so that's what the line of the graph of the exponential function should look like. Again, notice this purple line here, that's my horizontal asymptote. This red line, as we move to the left, is going to get closer and closer and closer to that horizontal asymptote, but it won't actually touch it. Now sometimes Desmos graph can look weird. You see how it's at 0.002? Eventually it'll get to a point where it just says, look, I can't round this anymore. So notice how here it says it's at 0, but it's really not. It's just we don't have any more decimals to represent it, so it doesn't actually ever intersect. So like see how here if we're trying to click where it intersects, it doesn't actually intersect, okay? It just says that because it gets so close it can't round it. So you got to understand they still aren't actually touching each other there. Okay. Screen 8, another one, similar. Now, shouldn't we know what these things do? The negative 1 on the outside, what does that do? Shift the whole graph down 1. The plus 2 on the inside, what does that do? Shift the whole graph left 2. All right, so as we go through these and we check these guys out, we want to keep these different things and these different scenarios in mind, okay? Now, again, I'll show it to you directly. Like, let's say you copy this, okay? Then you open a separate Desmos calculator. Alright, and because you're not sure and you don't want to just try in your head and then mess it up, right? And you will definitely probably have to do this for the logarithmic graph. So like it wanted negative 4, right? So you put that in here, see how we get negative 0.75? Awesome. So then that's my answer here, negative 0.75. And we already kind of know, shouldn't this graph kind of look, it should form that kind of upward looking curve, right? Alright, so now I'm going to just switch that to a negative 3 instead of a negative 4. I get negative 0.5. So let's change this mess to negative 0.5. There we go. Notice how it's making that nice little pattern we think it should. 0, so now let's put the 0 in here. Boom, boom, 0. Put in a 3, okay. So here we go, 3. Awesome. Okay, boom, boom, boom. Okay, now let's do it with the 2. There we go, 15. All right. Awesome. All right, and if you can't see that last point, just zoom out here with the minus sign, you'll zoom out. Let's go ahead and click on it, and there we go. There we see our general shape of the graph. We see the same thing. This blue dotted line represents that horizontal asymptote, right? So we went through all the points. We didn't touch the line. Remember, it's going to look like it gets closer and closer to it. It'll even eventually say negative 1, but it's not actually intersecting, okay? All right, so let's go to screen 9. Describe the shape of these graphs. I would say it's an upward trending curve, right? So it's a rising one-sided curve. All right, are there any xi's that gave us an undefined? No, we didn't have any undefineds, right? Are there any xi's that could be included? Yeah, sure, right? How do we show that? Arrows both directions, right? Okay, what is the name of the function? This is called an exponential graph. Do we have any asymptotes? Yes. What do we have? We have one horizontal asymptote. Okay? And do we avoid crossing the lines? We did not cross the lines. Okay? Alright, so there's our first two. So we had the rational graph, which had the two parts to it. Okay, the double-sided curve. And then here, we have the exponential graph, so it's this one-sided rising curve, right? Alright, so let's look at our other function here for today, which is the logarithmic. Now again, this would probably be the one I would expect you to know the least, and I doubt you would have seen it prior. Okay, so I'm going to type this in here, and I'm going to put in these numbers that we want. So in this case, what did it ask us for? It asked us for, 0.5, so I'm going to put a 0.5 in here, 0.5. So everybody see how it's -1, -1. Okay, now I'm going to put a 1 in here. We get 0. Now I'm going to put a 2 in here. We get 1. I put a 4 in here. We get 2. And really, what a log does is it helps us to find an exponent we don't know. Now, we haven't done anything in terms of solving using a logarithm, but just so you understand what it is that's kind of the idea of a logarithm. Okay, like say you needed 2 to what power is 42. Like I'm not sure, so we'd use a logarithm to help us solve for that exponent value. Okay, but here's the logarithmic graph. So what happens? It looks like it's going up really quickly, and then it kind of just flattens out. Right now, it still goes up like this whole time. This is still going up. It's just going up slowly, right? And we still have this asymptote. This entire purple dotted line is an asymptote right here, so it's a vertical asymptote. Okay, this is the parent function. This is what it looks like. Let's look at one that's had a transformation. Again, I hope you already kind of have an idea for what this should be and what should occur based on the fact that we have these numbers. The +3 on the outside shifts the whole graph up 3. The -2 on the inside is going to shift the entire graph to the right 2. So this is actually our vertex center point, 3, 3. Because if you notice before, it was at 0. It was at 1, 0. So then that whole graph has shifted right 2 up 3. So right 2 up 3, and then there you go. Okay. So let's plug our numbers in here. Again, I'm just going to copy this guy, and I'm going to show you this first one. I think this first one's pretty important here to check out. So check this out. We're going to switch this to a 2. Notice, undefined. You can't get a log 0 here, so this value is undefined. And that is the vertical asymptote, where x is 2. But notice the 1 was also undefined, so it's not just this like the rational graph. Any x value to the left of this is also undefined. Okay. All right. So now let's do this with 2.5. So we can go back up in here. We'll do a 2.5. We get 2. So let's put a 2 here. 4. We get a 4. 4, 4. 10. We get 6. Okay. So there's all ours. If you want to see that last one, you zoom it out, click on your button so you see what it looks like. Same setup, right? Same similar situation, same general look. It's just it's been shifted to the right 2 because the -2, and actually the whole thing's been shifted up 3 here. Okay? All right, so let's draw our conclusions here. All right, so to describe the shape of these graphs, I would say it's a one-sided flattened curve. Again, you don't have to have exactly what I have here, just as long as you know what the log function generally looks like. Are there any x values that don't give y value? Yes, right? So what were they, right? It was the asymptote, it was the vertical asymptote, and anything less than that, right? So like it wasn't just that it couldn't be 0, it was anything 0 or below it. It wasn't just that it couldn't be 2, it was 2 or below it, right? Are there any x values that could be included in the table? Yes. Doesn't this side go to the right forever? But notice, it doesn't go left forever. So how do we show the values? We'd have a one-sided arrow, right? We'd only be having, in terms of the x values, now you would draw an arrow going down. It does technically go down forever, right, to -infinity. But it never goes further left than just approaching the 2. But it does go further right. So you'd have that arrow going to the right to show the other x values. What's the name of the function? Again, we can just call it a log function. Do we have any asymptotes? Yes, we have one vertical asymptote. Okay. And do we avoid crossing lines? Yes, we did not cross the lines. Okay. Okay, so we've gone through each of the different graphs. We did the rational graph, we did the exponential graph, and now we just did the logarithmic graph. Okay, so now we're just going to kind of talk about the characteristics in 13, 14, and 15, those ones we've been talking about for the last month. So let's take a look at each of those. Okay, so here's my rational graph. We want to answer, all these different things we've been answering, okay? So first off, vertex center point's important on the rational graph. It's not so much on the log graph or the exponential graph. But there's my vertex center point. It's where the two asymptotes intersect. So -2, -4. So I'm going to put that. Now, what that also does is tell me what my asymptotes are. Isn't this horizontal line my horizontal asymptote? Well, what's that at? -4 for y. So I'm going to write my asymptotes for x and for y. So what's my x asymptote? Oh, isn't it just, it's -2, right? So I'm going to put x equals -2, and then y equals -4. Okay. Now, just jumping around here to different stuff. So, end behavior. I think the end behavior for the rational graph should be the easiest thing. Look, if I'm on the black line here. As I go further and further right, don't I just keep getting closer and closer and closer to that horizontal asymptote of -4? If I go further and further left, don't I again keep getting closer and closer to that horizontal asymptote of -4? So actually, on a rational graph, the end behavior in both directions is just whatever the horizontal asymptote is. So both of these should just approach -4. Okay, in terms of extrema, it would have to distinctly change directions. Like go up, then come down. Go down, then go up. It doesn't do that. So these are D and E. Okay? All right, for increasing and decreasing, we're actually going to answer the domain range first, and then we'll come back to them. All right, let's knock out the XY intercept. Those should be the easiest things every single time. So there they are, 0, -3.5. Please make sure you write it like a coordinate point. It needs to be like a coordinate point. Okay, and then the x-intercept at -1.5, sorry, -1.75, comma 0. All right. All right, domain and range. The domain. What is the domain? Okay, so the domain takes us left and right. So remember, this line actually goes left forever. This side goes right forever. So it basically is everything except this vertical asymptote, which is at what? Well, we already said it's at -2. So since this is a -2, we can't be -2. So one way you can write this is all real numbers except 2. And that's a totally fine answer and totally will work. Now you can't write the increase-decrease intervals like that, so you need to also know how to do it in what we would call interval notation. So the other way to do that is to say, well, it starts at -infinity, it goes all the way up to, well, what do we say? -2. So if it goes from -infinity to -2, and that really is like the domain for this side of the graph, this part over here. But then isn't there the other part? So then since there's a second part of the answer, we put union. And then we need to go from -2 to the right forever, right? That's this part of the graph. So now, that's what we write, -2 to forever, okay? So there we go, all real numbers except 2, -infinity to -2, union, -2 to infinity. So what about the range? Well, isn't it the same thing? Doesn't this side go down forever? Doesn't this side go up forever? So it's everything except, well, what is this horizontal asymptote? It's at -4, right? So the range, again, we could say all real numbers except 4. Or we say, hey, it goes from -infinity, sorry, to -4. And again, that just describes this part of the graph. It can't be -4, and then it goes from -4 up forever. So then we would say union -4 to infinity. Okay? All right, now in terms of the increase-decrease, for our last thing we need to answer here, well, let's look at the graph. So this thing goes down, then it doesn't exist at -2, and then it goes down. So really, it always went down. So the increasing is does not exist, and the decreasing is, well, it decreased all the time. So it decreased everywhere x existed, which would be this. So you can just copy and paste the domain right there. All right, that was the characteristic for a rational graph. Let's look at an exponential. Okay, I'm not actually going to use these. I think potentially here that could just be confusing, so I'm actually just get these out the way. Okay, let's start with the easiest stuff. X and Y intercept, 1, 0, and 0, -2. 1, 0, 0, -2. Okay. Let's talk about the domain. This graph goes left forever. This graph goes right forever. So the domain should be -infinity to infinity, or in other words, all real numbers. What about the range? Well, what is this asymptote at? Isn't this at -4? So really, we just answered this question. Y equals -4, that's the asymptote. It can't be -4, but can it be everything above it? So the range is from -4 to infinity. Okay. All right, so what about our end behavior? Well, as we approach -infinity, if we go left forever, what do we keep getting closer and closer and closer to? We keep getting closer and closer to -4, right? What about if we go to positive infinity? Well, if we keep going to the right, to the right, to the right, what do? We go up. So we go up to infinity, okay? Extrema, do we have a place where it changes directions, where it goes up, then down, or down, then up? No. Okay, look at the graph. If we start way over here on the left, what does it do? It goes up, 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 up. So it doesn't always go up. So my increasing interval should be the same as the domain, which was -infinity to positive infinity. So if it always goes up, when does it go down? It doesn't. Okay, the vertex center point, we're not going to ask you that from a graph without an equation. However, just so you know what it is, it's always just whatever that y value is for the intercept, it's 1 above that. So see how this y, or sorry, the asymptote. So see how the asymptote's at y equals -4? So let's find when y is -3. And there we go, -1, -3. Okay, so that's my vertex center point. All right, -1, -3. Again, we won't ask you that on a test at our level. Okay, let's do our last one. So again, I'm just going to move these out of the way for right now. All right, this is our logarithmic graph. So again, let's start here. Let's label some stuff. 3.25 comma 0, that's my x-intercept. 3.25 comma 0. As we see, isn't this my asymptote right here? X equals 3, so there's one of our answers. Asymptote x equals 3. Since that's my asymptote, do we ever hit the y-axis? No, so my y-intercept does not exist. Okay, extrema, does it change directions? Does it go up, down, or down, then up? No. Let's look at the graph now. Where are we at? We're at 3, and then everything from there is to the right. So what's the domain? Well, it's from 3. We need a parenthesis because remember that vertical asymptote means it can never actually be that number. So we don't want to bracket because it would include the 3. So 3 to infinity. What about the range? Well, this side goes up forever, but this side goes down forever. So really, the range is all real numbers. Or again, you could write, the -infinity to positive infinity. Okay? All right, so now all we need is the decrease, increase, and then our end behavior. So let's look at the end behavior. The end behavior as x approaches -infinity. Do we ever go to, we never go to -infinity, so we can't even answer that. What about the end behavior as it approaches infinity? Well, if we go to the right, what are we doing? We're going up. So it goes up continuously, or in other words, to infinity. Okay, increase, decrease. Well, doesn't this entire graph, it always goes up, right? So starting from here, it goes up, 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 up. So the increasing should be everywhere that the graph exists, which is from 3 to infinity, right? And you can also just feel free, that answer is the same. You can just cut and paste it. Well, if it always went up, it never went down. Okay, vertex center point. So I said before it was 1 for the exponential graph. It was the y value 1 above the horizontal asymptote. For the log graph, the vertical asymptote is at x equals 3. I need 1 above that, so I need where x is 4. So I'm going to find where my x is 4. There's my point 4, 2. Again, you will not be asked that on a test without an equation. Okay. From here, your asynchronous work is to make sure you do screens 17, 18, 19, and 20. So please make sure you go through those. Make sure you're continuing to work on the Delta Math assignment and obviously working through your quests. Hope this helps.